Alright, so calculus is the study of rate of change of one quantity, WRT, with respect to another, okay? i.e. something like the distance travelled varies, how distance travels varies with respect to time taken, okay? So the speed of a car is the rate at which the distance travelled changes with respect to time. So remember, speed equals distance over time. So just put it there for now. And we'll just move on. Just to remember and note that if we had a function y equals 2x, and if we were to put values of x 0, 1, 2, 3, 4, 5, 6 and calculate the y output, then we would get a set of ordered pairs that we could plot as we've plotted here, and we would see that this function y equals 2x would give us a straight line plot. Okay? And if you remember the form of a straight line, it's normally y equals mx plus c. Now we don't see any plus c here. That's because that's where c is where a line cuts the y axis, and that's at 0 here. So there's no c here because it's 0 anyway. Okay, and if you recall then that when we had the equation of a line in the form y equals mx plus c, or the form of the linear equation when plotted, which gives a straight line, that the m stood for the slope. Okay, and as I've just mentioned, the y-axis intercept was the constant. Okay, but what actually does slope mean? Okay, so what does slope mean? The slope tells us how much y changes, for a 1 unit change in x. Okay, so, or as we recall as well, the slope we calculate slope as the rise over the run in coordinate geometry, rise over the run. So in this, if we were looking to find the slope from the graph of this line here, we could just take this point to this point, and we note that the rise is 2 and the run is 1. So 2 over 1 is 2. And we know from just from the equation of the line that just by looking at the equation, we're not doing any calculations, the slope is 2. So just bear with me here, we'll just get through this, we are coming to a conclusion. But what we're trying to say is that the slope of a line gives us a rate of change in y with respect to x. That's what the slope of a line tells us, how much y is changing with respect to x. And with that in mind now, that the rate of change in y with respect to x is the slope, we're going to start to use this notation dy dx to represent slope. Okay, and we're going to see that there's another way to find the slope of a function. Could be a straight line, could be a curve. There's another way to find this slope, this dy dx of a line, and the line, let's say, is straight or curved, and that's to use this notion of differentiation or differentiation. Okay, I'm saying that the difference from differentiation is out of the fact that when we start to consider the first difference of the outputs of any given function, of the equation or function, and also how y differs with respect to x. Okay, so let's look at the slope in another way. Let's say we have our function y equals 2x, and we have our domain, our inputs 0, 1, 2, 3. Plug those in, and we get our range of outputs. So when x is 0, y is 0, x is 1, y is 2 from this equation here. And if we notice the difference between the y outputs, 0 to 2 is a difference of 2, 2 to 4, difference of 2, and 4 to 6, a difference of 2. We met this first difference notion when we did the functions chapter. But the two things to note there, that first of all, it's constantly 2 for this function. and the second thing is it's 2, but so is the slope of this function, which we kind of worked out at the beginning of the sheet. So we can conclude that dy dx, which is the slope, is also equal to the first difference value from the outputs of the function. Okay, and there's just this rule now that we're going to take on board, very important rule, that for a linear function in the form y equals ax plus b, or sometimes we see it as mx plus c, but let's go with y equals ax plus b, then dy dx is equal to a, is equal to this value here, is equal to the slope. So if y equals 4x, dy dx of the slope is equal to 4. If y equals minus 3x plus 5, dy dx is equal to the slope minus 3. If y is equal to half x plus 6, dy dx is simply equal to the a value, a half the slope. And before we do an example, if y equals ax plus b and dy dx is equal to a, the slope is equal to a, what happens if we have a function that's simply equal to, say, y is equal to 6, so there's no x in the function at all, and that can happen because y equals 6 is simply, if we say y equals b, so not 6, y equals b, so just y is equal to some constant b, okay? Let's say y equals 3, if we were to plot that, this is the line y equals 3, and the slope of that line is 0. And you know, y equals b, so dy dx is 0 because there's no x or x coefficient a. This doesn't exist. So the slope of any function y is equal to b, say y is equal to minus 9, slope is 0. Okay. So let's look at some examples. An aunt decides to give her niece €50 pocket money on the 1st of January and increase it by €10 per year from then on. What is the rate of change of pocket money with respect to time in years? Okay. Well, let's just generate an amount equation. The amount that the niece will have is equal to the 50 that she was given at the beginning plus €10 every time, or per x per year. Okay, so if x is 1, she'll have €60 at the beginning, x is 2, she'll have €70 and so on. Okay, so that's the equation. So the rate of change then is the dy dx, is the rate of change, it's the slope. Okay, but in this terms there's no graph, it's just a story. But if y is equal to 10x plus 50, the rate of change is equal to 10 euros per year. It's the a value of the y equals ax plus b. A train travels at a steady speed of 80 kilometers per hour. What is the rate of change of distance with respect to time in hours? It's simply 80 kilometers per hour. A sunflower is 5 centimeters in height when bought and grows 3 centimeters per week after that. What is the rate of change of height in relation to time? Well, the height y is equal to, it starts off at a height of 5 and it grows 3 per week, per x. So if that's our equation in the form y equals ax plus b, then dy dx is simply equal to the a value, which is 3. The rate of change is 3 centimeters per week. And here's question 4 from your book. We have a graph here, and it's find the rate of change of y with respect to x. In other words, dy dx for the line joining a to b. So what's the rate? What's dy dx there? Well, dy dx is the rise over the run. It's 4 is the rise over 2. It's 2. From b to c, it's dy dx is the rise over the run. It's 0 rise because we're not going anywhere, and 2 over 2, but it's still 0. And from c to d then, dy dx rise over the run, but this time we're going down 1, so it's minus 1, and we're going to cross 1 over 1, it's minus 1. And from d to e, it's the rise over the run, it's going down 3, 3 places over 1, so it's minus 3 over minus 3. So it's negative as this line is decreasing.